Until you experience a power cut, it can be easy to forget just how transformative the energy transition has been for our lives, societies, and economies. For all human history, until the 19th century, almost all the power to create and move things, or cook and keep us warm, came from human and animal muscle and biomass, such as wood and peat. In 1800, at the beginning of the Great Transition, total global energy consumption was around 5.6 thousand terawatt hours. Today, global energy consumption is fast approaching 180,000 terawatt hours, over 30 times what it was 200 years ago. By examining energy consumption in the first and second waves, we can expect global energy consumption to more than double today's consumption by 2100. This video will help us to understand why. First of all, the term energy transition is today normally associated with the transition to renewable energy. That kind of green energy transition we describe as the Energy Transition 2.0. The energy transition that forms part of the Great Transition we describe as the Energy Transition 1.0. Let's start at the beginning of the Energy Transition 1.0. In the 18th century, the countries of the first wave began their transition from natural sources and methods of obtaining energy to technological ones. The energy transition in the first wave began with a revolution of coal and steam engines. Without the invention of the means to convert steam to power machinery, we would not have been able to increase productivity or GDP. Coal powered the factories, trains, ships, and other machinery, which in turn powered the initial transition of the first wave countries. By the end of the 19th century, electrification powered by coal-based power plants began. And we emphasize coal here for a reason. The first wave countries' development for over 150 years was powered almost entirely by coal. We cannot make this point strongly enough. If we look at the case of England and Wales as an example of a typical first wave country, until the mid-20th century, over 90% of total energy came from coal. However, the transition in the first wave did not stop with coal. Virtually all the energy technologies known to us today were created between 1750 and 1950. These technologies used all types of energy resources known to us today: coal, oil, natural gas, hydro, nuclear, solar, and wind. First-wave countries were able to generate not only huge amounts of energy for its industry, but also its transport, electricity, heating, and much more. However, different technologies and energy sources were needed to power new sectors. For example, in the transportation sector, oil powered the growth of the car and aviation industries from the beginning of the 20th century. Gas provided a new source of heating and cooking for households and was used to power new power plants. By the end of the 20th century, many first-wave countries reached a peak in energy consumption. In fact, in some countries, it is now falling very gradually. In other words, many first-wave countries completed their Energy Transition 1.0. Scientists such as Václav Smil have demonstrated the strong correlation between energy consumption and economic growth. One can draw an almost straight line on a graph of GDP per capita and energy supply per capita. We can see a similar correlation in the relationship between the Human Development Index and energy supply per capita. You cannot build a new factory if you do not have the coal or electricity for this factory. You would not invest in a car plant, for example, unless you knew you had access to a dependable and cheap source of electricity. If a government wants to increase GDP, it needs to secure access to hydrocarbons and build power plants. So how much energy does an urban industrialized society consume per capita? To what level of consumption can we expect all countries going through the Great Transition to aim for? We know that an agrarian society consumes between 500 and 3,000 kilowatt hours per capita. If we look at today's energy consumption per capita in first-wave countries, we can see that in Europe, energy consumption has reached over 30,000 kilowatt hours. Germany is closer to 45,000 kilowatt hours per capita, and in North America, it has reached almost 90,000 kilowatt hours. So we might take 40,000 kilowatt hours as a conservative estimate, a rule of thumb for energy consumption per capita for an urban industrialized society. This means that for a global population of 10.8 billion in 2100, we can expect a global energy consumption of over 400,000 terawatt hours, well over double what it is today. Before we go any further, let's be clear about what we mean by energy. Today, the world consumes around 180,000 terawatt hours of energy. 80% of this comes from burning three hydrocarbons, so-called fossil fuels, coal, oil, and natural gas. Just over 40% of energy is consumed by burning oil products in combustion engines for transportation. A further 10% of energy is consumed burning coal in the industry sector. 16% is consumed by burning gas in the industry sector and in residential and commercial buildings. 10% of energy is consumed as biofuels and waste. And only 20% of energy is consumed in the form of electricity, over 60% of which is created using coal and gas power plants. And the other 40% comes from nuclear, hydro, as well as a small amount from solar and wind. In other words, energy is not only electricity. Unsurprisingly, economic growth in the second wave has similarly been powered by a growth in energy supply. The largest second wave country, China, went from around 1,500 terawatt hours in 1965 to around 40,000 terawatt hours today, a 27-fold increase. If you are already juggling too many numbers in your head, then let's focus on the most important indicator of the energy transition: energy consumption per capita. Today, we can see China has reached over 28,000 kilowatts per capita, suggesting it is approaching the completion of its energy transition. If we look at official Chinese government forecasts, we can see that they plan for China to increase energy demand by another 30% over the next 20 years. In other words, taking them to around 36,000 kilowatt hours per capita. In absolute terms, this means China alone in 2040 will consume the same number of energy as the whole world consumed in 1970. What we can also see is that China's economic growth and human development was driven, much like in first-wave countries, by fossil fuels, particularly coal. China had its own coal fields and resources, and coal powered its economic growth and urbanization. They built coal-powered blast furnaces to produce steel, to build the factories, cities, and infrastructure for urbanizing more than 1 billion people. And the cities, factories, and even agriculture needed electricity. So China built around almost 2 terawatts of power plants, installed capacity total. Over half is coal. Coal has been the foundation of economic progress for China for the last 40 years. There may be great headlines about China's significant investments in renewable energy recently, but China is not closing its coal power plants. These new renewable energy sources are not to replace existing infrastructure, simply to meet additional energy demand. In transportation, we can see that since 2010, China has seen a rapid increase in personal car ownership. By 2050, we can expect there to be 500 million cars, double today's figure, increasing oil demand. We can see a similar story in other second-wave countries, such as Brazil, Mexico, and Turkey, who have increased their energy consumption between 10 and 20 times since 1965, and reached an energy consumption per capita of roughly 25,000 kilowatt-hours in Brazil, 17,000 kilowatt-hours in Mexico, and 23,000 kilowatt-hours in Turkey. Coal has been less of a factor in energy consumption in these countries, but it has simply been driven by other fossil fuels, such as gas. Brazil is also unique in that its water resources, the Amazon River, allow it to power 3/4 of its electricity production using hydro. Thanks to their early start in the energy transition in the mid-20th century, the first-wave countries, just 700 million people, accounted for 80% of global energy consumption. And the rest of the world, 2 billion, consumed the other 20%. Today, the first wave's 1.2 billion citizens account for a mere 30%, and the second wave's 3.5 billion citizens for over half of global energy consumption. What's more, the second wave can still be expected to increase their per capita energy consumption another 50% or so before completing their transition. And we still have much more growth from 3 billion people living in the third and fourth wave. The third wave countries only began their energy transition at the end of the 20th century. Today, India, the largest of the third wave countries, has an energy consumption of still just 7,000 kilowatt hours per capita. While far larger than the 1,200 kilowatt hours in 1965, it is far behind its first and even second wave counterparts. We can expect its per capita energy consumption to increase at least 5 times before it completes its transition. The Indian government understands this very well and plans to quadruple total energy consumption by 2047. And much like China and other first and second wave countries, coal today is the largest source of energy, and coal will continue to play a crucial role for many years to come. Today, coal supplies well over half of India's energy consumption, and it looks set to continue to do so. Oil provides another third or so of India's energy consumption. But India has only 30 cars per 1,000 people, as compared to 500 cars in European countries and 800 in the U.S. The fourth wave countries have the furthest to go. Fourth wave countries still live in the agrarian era and do not yet have the necessary energy infrastructure. Today, fourth wave countries have a per capita energy consumption of only 1,000 kilowatt hours per capita, although there are significant differences between countries. On a per capita basis, it needs to grow 30 times larger to reach first wave human development levels. We know that fourth wave countries need to build at least 2,000 gigawatts of power plants for 2.5 billion people in 2050, 40 times more than today. When we consider that its population is also set to grow by another 3 billion people this century, then we can expect its energy consumption to grow by around 100 times. Considering Africa's growing population, that means it looks set to consume, as a continent in 2100, almost as much energy as the whole world does today. Those in the energy sector may understand why that is a large enough challenge without the elephant in the room: the additional demand to make the fourth wave's energy transition carbon neutral. Many international organizations and first wave countries are concerned about third and fourth wave countries' growing energy demand and are pushing them to not burn fossil fuels. This is the Energy Transition 2.0, the transition to renewable sources of energy to prevent climate catastrophe. The challenge is that the technologies used to power the growth in human development in the first and second wave countries all rely on fossil fuels, coal in industry, oil in transportation, and so on. First and second wave countries, having completed or almost completed the Energy Transition 1.0, have begun this Energy Transition 2.0, but they are at a very early stage. In a later video on green technology and climate change, we will discuss in more detail why third and fourth wave countries cannot simply build clean energy infrastructure instead of fossil fuels, and in fact, why even today the first wave is unable to eliminate coal consumption. But as fourth wave countries understand, unless they do burn fossil fuels, they cannot develop. Today, global energy consumption is approaching 180,000 terawatt hours. The growth in energy demand in the rest of the 21st century is inevitable and predictable. We understand that once the energy transition is complete, global per capita energy consumption will rise from agrarian levels of 500 to 3,000 kilowatt hours to around 40,000 kilowatt hours. So we can safely project that with a global population of 10.8 billion, global energy consumption will reach at least 400,000 terawatt hours, over double today's consumption, to power our transport, our industry, and our homes. And as we can see, growth will come mainly from the third and fourth waves. This challenge is hard enough without considering the need to decarbonize both existing and future energy supply. Without an energy miracle, now the third and fourth wave countries will need to use fossil fuels to secure their human development. We may be justifiably concerned about the implications for climate change, a topic we cover in more detail over the next two videos. But it was fossil fuels that secured first and second wave countries' current levels of human development.